Hello, my name is Julie Goodwin, and this is my Life of Mammals project, the Ecological Niches and Adaptations, a comparative study of hyraxes and chuckwallas. This project is mainly focused on the hyrax, therefore most of the information will be regarding this animal. Some key points that we will be touching on are the hyrax mammalian order, chuckwalla introduction and selection criteria, Hyrax characteristics, conservation status, and ecological role, Hyrax adaptations, and Hyrax and chuckwalla comparative analysis.
The Hyrax mammalian order is the Hyracoidea. Order Hyracoidea is comprised of at least 5 subspecies in 3 genera, Procavia, Heterohyrax, and Dendrohyrax. Procavia consists of the rock hyrax or Procavia hyrax, which has the largest distribution of all the hyraxes. The Heterohyrax consists of the yellow-spotted hyrax and the bush hyrax, which both go by the scientific name Heterohyrax brucei. And lastly, the Dendrohyrax consists of the tree hyrax, the largest of them all, and goes by the Dendrohyrax dorsalis. Hyracoidae are significant in their common ancestry relating them to elephants and manatees, as well as being an atypical ungulate by having a small body.
Chuckwalla of the order Squamata are a group of American desert-dwelling reptiles, scientific name Sauromalus ater. Some factors contributing to the selection of the chuckwalla to compare with the hyrax are their thermoregulation behaviors, hind feet morphology, habitat, and their diet, which we will discuss shortly in further detail. Before delving into the comparative analysis, it is important to understand some Hyracoidae characteristics and adaptations. Hyracoidae have robust, rabbit-like bodies covered in fur that are often described as stout. They are herbivores and are found to have unique features on their feet. On their forelimbs, they have 3 toes, while on their hind limbs, they have 4 toes, which helps to propel them forward and up while climbing rocks. They also have hoof-like nails on each digit, which are an ungulate-like trait. Their conservation status is least concern, as they have currently no population decline. Relating back to their herbivore behaviors, their ecological role is vegetation control, as they graze the vegetation in their areas. Beyond the adaptations found on the feet, hyraxes have developed an array of adaptations to withstand the hot, arid climates in which they reside. In terms of physiological thermoregulation, hyraxes are found to be quite inefficient, as only 2 characteristics are of importance. That is, their renal function, capable of retaining great amounts of urea and electrolytes, which helps to preserve water, as well as their ability to function with minimal water intake. The rest of the hyrax's thermoregulation relies on their behavioral adaptations. That is sunbasking, which usually happens in the mornings, as well as piling together and cuddling to retain body heat, and crevice dwelling, where they reside in a small hole in rocks in order to preserve heat. To survive desert environments, Hyracoidae were required to adapt their body to what diets were available. This includes vestigial teeth and tusks for mowing vegetation. The vestigial teeth in the maxilla are reminiscent of sirenians, which previously mentioned manatees are closely related to the hyraxes. As well, the hyraxes have 3 fermentation chambers in the digestive tract, which are able to digest otherwise poisonous Solanaceae and Euphorbiaceae. A significant adaptation of the hyrax is related to their feeding strategy. As prey animals that rely on the safety of their rocks or vegetative structures, feeding requires specific behaviors, such as staying in groups, as there is safety in numbers, and having lookouts and warning calls.
Here is an example of a warning call that a Hyrax will do in case of a predator to warn the rest of their group. For the comparative analysis of the Hyrax and Chuckwalla, we will begin with the habitats. Both Hyraxes and Chuckwalla mainly reside in desert climates, specifically amongst rocks. However, it is intriguing that both also have subspecies that take up forest or bushy territory. Next is the hind feet morphology, which is a very important adaptation for both needed to thrive in the habitats that they are in. The hind feet of both Hyraxes and Chuckwalla have evolved over time to become better adapted to climbing rocks and natural surfaces. Hyrax have 2 more digits in their hind feet compared to the front, which help to propel them forward. Rather than developing more digits, the Chuckwalla evolved to have larger hind feet. Further, the claws of the Chuckwalla for grip are similar to the Hyrax's sweat glands and ungulate-like feet to help them grip. These are very interesting tactics and different ways that they both evolve to achieve the same goal. Next is thermoregulatory behaviors. Although Chuckwalla are ectothermic and Hyrax are endothermic, both rely heavily on sunbasking for body heat, specifically in the mornings. Chuckwalla have not been documented to cuddle as Hyrax do, as they have less group behaviors. Lastly is the diet. In order to adapt to minimal water sources in hot environments, both Hyraxes and Chuckwalla developed a strategy that requires little to no drinking. Although in different areas of the world, both seek annual, perennial, and deep-rooted plants that provide enough moisture to sustain the animal. Finally, to review some key points, let's remember the Hyrax order Hyracoidae and their remarkable digestive, dentary, and behavioral adaptations. One of the more major things to remember are the hind feet adaptations of both Hyrax and Chuckwalla that are different yet accomplish the same goal. Thank you for your attention to my Life of Mammals project regarding Hyrax.